Jai Hind to all of you. I am Updesh Kumar Jaiswal, working as an assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to discuss about the topic type conversion and typecasting in C++. It is related to subject object oriented programming KOE 064 subject code in the AKGEC. Before starting, firstly, we should understand some C++ basic data types and their sizes. In case of C++, integer data type takes 4 bytes, short 2 bytes, float 4 bytes, and double takes 8 bytes in the memory. In case of character, it takes 1 byte. A sky value of some characters in C++. I am giving some examples of the sky value of some characters used in C++. Suppose here I have written capital A and its sky value is 65. In case of small a, its sky value is 97 and so on. Const keyword in C++. This is very important keyword to understand the type conversion and typecasting. So, the const keyword is used to define the constant value that cannot change during program execution. It means once we declare a variable as a constant in a program, the variable value will be fixed and it will be never changed. If you try to change const type variable, then it shows error message during the compilation and running of the program. We can use const variable in many places. I am giving the example of const keyword used with the variable. A const variable is used to define the variable values that never be changed during the execution of a program. And if you try to modify the value, then it throws an error. The syntax of const variable. Firstly, we will write the keyword const, then data type, integer, float or double, and variable name. It may be ABC. Now I am going to explain a program to use the const keyword in C++. Here, firstly, I have written the 2 lines of code, including the header files. In the main function, I have declared the value of the const. Here, const keyword used and data type is integer. The name of variable is num and value is assigned to the 25. Here, we are trying to change the value of the variable num, which we have already defined the const. If you are doing this thing, then after the compilation of the program, after the running the program, an error message will be shown. Now, the main topic is the type conversion. C++ programming language support 2 types of type conversion. Firstly, implicit type conversion, and second one is the explicit type conversion. I will discuss each one. Implicit type conversion. Implicit type conversion is automatic. There is no interference from the user in this type of conversion, and the compiler directly carry out the conversion. Conversion is usually done when in an expression there is more than one type of data. But generally, in this type of conversion, there is a possibility for loss of data, loss of signs, or overflow of data. These are some problems. Implicit conversion. In implicit conversion, the compiler carry out the conversion from one data type to another whenever an expression has more than one data type. In order to prevent loss of data, all the variables of the other data types are converted to the larger data type. Suppose there are 2 variables, integer and float. in a expression, then we will convert integer into the float of the bigger data size. This is called as the promotion. Here I have given one example to show the implicit type conversion. I have written a program in C++, include IOSTM. In the main function, I have taken a variable with name num, data type is integer, and value is initialized equal to 10. Another variable is ch of character type, and it is the capital A in the single quote. We want to show in the output 10 plus A. So in output 10 plus A, the sky value of A is already shown 65. So here type conversion will occur, and 10 plus 65 is equal to 75 will come as a output. In the second segment of the program, here I have taken another variable where it is of the sort type, value is 1000, and another variable is where int, it is of the integer type. Here where is assigned to integer where integer, and we want to show output, then output will be float val 10 plus A, and the sky value of A already shown is 97. So 10 plus 97 is equal to 110, and in this case where int will be the 1000. So this is the output of this program. Now second type of type conversion is explicit type conversion. In case of explicit type conversion, in this user defined conversion, and it is normally called typecasting. Here the user converts a value of one data type to another depending upon the requirements. These type of conversion are safer. So explicit type conversion is also called as the typecasting, and we can perform typecasting using the many methods, and the first is the using assignment operator. So we are going to perform explicit type conversion or typecasting using the assignment operator. Explicit conversion or typecasting using assignment operator in a way is performed forcefully. Here we cast or convert one data type to another data type by using a assignment operator. Here assignment operator is used for the type conversion. The general syntax is given here. Firstly, we write the data type like integer, float, double, and then we will write expression and then semicolon. The following example explain this. I have given one example program of the C++ to explain the explicit type conversion using the assignment operator. Here header file are included. In the main function, I have taken a variable with type integer. Salary is another variable of type double. Sum is equal to integer in the bracket, then salary. Here data type, then expression. So we are performing the explicit type conversion using the assignment operator, and 1000 is added in this, and this value is assigned equal to the sum. When we will display the output, the result will come 4563.75 will be converted into the integer, and it becomes 4563, and after the adding the value 1000, the result will come 5563. Now in the next segment of the code, we have have taken another variable with the name comp. It is of the double type. Here also the explicit type conversion is performed using the assignment operator. Here the assignment operator is given. Here sum, which was earlier becomes the integer, now it is converted into the double, and the result is showing in the floating point. And after adding the 0.020, the value will be 5563.2. This will be the output. Now another method for the explicit type conversion is using the cast operator. In this type of casting, we use a cast operator, which is a unary operator, to change from one type to another. So using the cast operator, we can perform the explicit type conversion by many methods. And the first method is static cast, another is dynamic cast, then another is reinterpret cast, and last is the const cast. I am going to discuss each and every one by one. In the case of static cast, the static cast is the simplest among all typecasting using the cast operator. The static cast is able to perform all the conversions that are carried out implicitly. It means it is performed by the user. It also performs conversions between pointer of classes related to each other from derived to base or downcast from base to derived. Apart from the above listed conversion, the static cast is also able to convert any pointer to wide string. The static cast is the compiler time cast. This means there is no check made at the runtime to see if the cast perform is valid or not. Thus, it remains the responsibility of the programmer developer to ensure that the conversion was safe and valid. It is the wholesale responsibility that the conversion will be safe or valid, and this responsibility taken by the programmer or developer. To show the example of the explicit type conversion using the static cast, I have written a program. Here, before written the program, syntax is given. Here, static cast keyword is used in case of static cast explicit type conversion. New type after the conversion, which data type we require, and the expressor. To understand this thing, to understand the static cast in case of explicit type conversion, I have written a code here. In the case of main function, I have taken a variable with name df and data type is the double, and its value is equal to 3.5 multiplied by 3.5 multiplied by 3.5. In the output, before casting, the df value will be multiplication of these three terms, 3.5 multiplied by 3.5 multiplied by 3, and it will come 42.875. So it is the value before the casting. Now, next segment of the code, I taken another variable with the name total. It is of the integer type. Here, static casting is performed. Here, the keyword static cast is written. New data type is integer, and the expression is df. So after static cast, the value of total will be 42, because we have converted the df, we have cast the df, which was earlier the double, into the integer. Here demotion is occurred, so no problem. In case of explicit, promotion and demotion both can be occurred. integer can be converted into the float and float can be converted to integer. It depends about the programmer. It depends upon the requirement. It is the specialty of the explicit type conversion. Now, another is dynamic cast. So I am going to discuss about the explicit type conversion using dynamic cast operator. The dynamic cast is a runtime cast operator used to perform conversion of one type variable to another only one class pointer or and references. It means it checks the valid casting of the variable at the runtime, and if the casting fails, it returns a null value. Dynamic casting is based on runtime identification mechanism that is called as the RTTI mechanism. To demonstrate the explicit type conversion using dynamic cast, I have written a code in the C++ here. Firstly, header file is included, hash include ifstream. Now, a class with name parent is defined. In the public field, a method is defined. Return type is void and it is virtually defined. Now, a derived class with the name derived is inherited publicly from the parent using this code. In the next segment of the code, the main function is written. Here, we are creating an object ptr by using the code parent strict ptr is equal to need write semicolon. Now, we use the dynamic cast to convert class data using this code. Derive strict d is equal to dynamic cast derive. Here, this is the keyword. This is the syntax. Now, check whether the dynamic cast is performed or not. If d is equal to null and if it will not null due to this code, else see out dynamic casting not done successfully, because d will be not equal to null, so this output will be displayed due to dynamic casting. So it was the program which was showing about the explicit type conversion using the dynamic cast. Now next is reinterpret cast. This type of cast is most dangerous. So it is used very less time, and it works on any type of object without the classes being related to each other. Reinterpret cast work on any pointers, and it converts a pointer of any type to any other type irrespective of whether the pointers are related to each other or not. It does not check if the pointer or the data pointed to be the pointer is same or not. The cast operator reinterpreted cast takes only one parameter, the source pointer, to convert to and does not return any value. It simply converts the pointer type. We should not use reinterpret cast unless required. So it should be used very less time. We usually typecast the source pointer to its original type. We use interpret cast mostly to work with bits. When reinterpret cast is used on Boolean values are converted to integer values. For example, 1 for true and 0 for false. So, in the form of summary, we can say the reinterpret cast type casting is used to cast a pointer to any other type of pointer, whether the given pointer belongs to each other or not. So we can say it does not check whether the pointer or data pointed to by the pointer is the same or not, and it also casts a pointer to an integer type and vice versa. Here, syntax of reinterpret cast type is written. Either the keyword reinterpret cast is used, data type, and then expression. So it is the syntax of the reinterpret cast. So to explain this concept, I have taken one example. In case of example, I have taken a program written in the C++. Here hash include ion stream is written to header the input IDB stream file. In the main function, I declare the pointer variables. Integer asterisk pointer is equal to new integer 65. Now to use reinforced cast operator to typecast the pointer variables, here this code is written. Character asterisk C is equal to reinterpret cast character asterisk PT, and in the output these two things will be displayed. After this, we are getting the value of the defined variable using the pointer, and these two line of codes are written, and lastly return 0. After execution of this code, the value of PT will be this, the value of CH will be A due to this line, and due to this line the value will be 65 and A. Here the SKY value of capital A is taken as the 65 and address is taken. So this is the one of the example of reinterpret cast in case of explicit type conversion. Now fourth method of explicit type conversion using the cast operator is const cast. Here const keyword is used and cast is used for showing the explicit casting. Here the type of variable and then expression is written, and then lastly semicolon. Program to use the const in C++. I have written a code here, I have written a program here. Hash include IO stream. Firstly, a function is defined, integer display, and parameter is pass of the pointer type, and the pointer is of the integer type. Return asterisk pointer multiply by 10. In the next segment of the code, main function is written. Here a const variable is declared, const integer number is equal to 50, const integer asterisk pt, get the address of the num using this code. Now we use const to change the contents of the source pointer. Integer asterisk ptr is equal to const integer asterisk pt, and see output, and the output of this code will be the value of the ptr cast is equal to 500. The 50 will be multiplied by 10 and the value will become the 500. So this will be output due to const. So this is all about the typecasting and explicit type conversion using the cast operator. These are the references which I have used to make this lecture, to deliver this lecture. I have used 5 textbooks, 3 websites and 3 journals research paper to prepare this lecture. Thank you and Jai Hind.